Good morning. Anthony, are you? Yes, yes, sir. අදාළ අපි තවුදට පස්සේ ගියා. දැන් විනාඩි දැන් 10ට එන්න විනාඩි 3ක් කලින් දානවා. ඕකේ ඔය ලෑලි ටිකේ වැඩ ඉවර කරලා. අන්න විවහත් වෙනවා නේද? ස්ක්‍රීන් එක වයි ගන්නවා. විවහත් අයියා බබා පොඩ එන්න මම පුරුද්දට මේ මයික් එක ගැහුවා මම ඊයේ කරේ මේකෙන්නේ හරලා මට දුන්නා නෑ අවුලක් නැද්ද මයික් එක අවුලක් නෑ YouTube අරක නේද රෙකග්නයිස් කරන්නේ මොකෙන් හරි ඇහෙනවද බලන්න මගේ අතින් මොනවද කොහොමද අද ඉස්සර මයික් එක ගහලා සිස්ටම් අවුල් පොඩි මයික් හදලා මේකේ ඒ කාමාරක විතර නැගලා පන්ති පටන් ගන්නවා friction පටන් ගන්න නේ අද පටන් ගන්නවා නේ පටන් ගන්න Good morning children who is there today is the last YouTube class from next day onwards there will be no YouTube classes half of you sometime maybe the full class or half of you here others can join from home but not YouTube we will be using Google Meet communication on either side right now we have to start friction today by last week we have finished smooth joints smooth joints finished then friction මම කිව්වනේ පටන් ගන්නවා කියලා so what is friction friction is something you see almost everywhere in your day-to-day life right with no friction here I will not be able to stand like this bruise galai ila kohena tiddanne friction in two words it's a resistive force a resistive force so let's explain it mata vinadiya den mata වැඩි මතකයක් තුන්නේ අද friction right what is friction now here first thing friction we can speak about friction in three states solids liquids and gases liquids gases taken together fluids right in solids and fluids but here in the maths class we will be restricted to the solids only right This is not in the physics class, maybe. Yeah, yeah. What do you call it? Surface tension, maybe viscosity. Anything about तुलना करना है properties viscosity, maybe. So it's the friction, right, in fluids. Uh, now, now we will be considering only solids. मैं और उधर उधर के करांगे तो उधर बालन पाई ना और उधर के करना है नहीं क्या नहीं करना right one two solids the surfaces of two solids are in contact hmm, are in contact. Now I am applying a force on one of the objects. My intention is to move the surface relative to the other. I want to move it. But applying, say, I'm starting from zero, gradually increasing the force, this force, right? Yeah, with a little force, will it change? If my force is very little one, hmm? No, with a small force of, of a very small magnitude, you will not be able to force move it. To make it moving, you will have to increase the force, right? That means, in short, when you try to move it, we are applying a force intending to move it. So there is something. Now take it, retain it. Hmm? Like technically saying, some resistive force which tries to keep it in equilibrium, right? So that's what in our consideration today. So I'll go and let's explain. So surfaces of two solid objects are in contact. Hmm? Uh, right. So naturally there will be the normal contact force between them, the reaction, right? And now we are applying some external force. Our intention is to move one of the surfaces relative to the other. Say we are applying an external force P, right? An external force P is acted on one of the objects intending to move it relative to to the other, relative to the other, right? Of course, I have to mark the weight. There's another force. Right. The thing is, if the force is very small, the object will not force. There is something like preventing it moving. Hmm? That means there should be some resistive force which exerts between the two surfaces. Hmm? Some force F. Naturally, it exists naturally, a natural resistive force. Hmm? Then a natural resistive force F will exist between two surfaces, between two surfaces, uh, yeah, between two surfaces, which will try to retain the to prevent the motion. This occurs, right? This occurs always. It occurs, right? It's a natural phenomena, and that force, it is this force that we call the frictional force. Hmm? F is called the frictional force between two surfaces. Between two surfaces. Okay, now that's what we see. Now we are building up a theory upon that, right? So, what is the theory? Uh, Now, what if this force is zero? That P is zero. What about F? If there's no P, what about F? I'm not pulling it. Then the frictional force, yeah, it will be zero. No P, no F. Hmm? Uh, no P, no F. Yeah. If not, if F remains, එහෙම නාර හොල්මන් ගෙවල් වල වගේ නේද? මොනවද පොට්ට හැරි. ටීම් වල දිනවා වගේ නේද? This should without any force, this should move backwards. Good morning, Abhita. Uh, so if P is zero, F will also be zero. So F will not exist without P. So it is the force P, the external force P, which generates its own resistive force F. එහෙම තමයි නේද? මේ ස්වභාව ධර්මයේ අපි මොනවද කරන්න කියත් අපි කරන්න හදන දේ නිසාම අනිත් පැත්තට රෙසිස්ටන්ස් එකක් එනවා. අපි මොනවා කරන්නේ කරන්ට් එකක් කරන්න ගියත් එහෙමයි. මේ අපේ රටේ වගේ රටක හොඳ වැඩක් කරන්න ගියත් එහෙමයි. රටට ලෝකෙට යහපතක් කරන්න ගියත් එහෙමයි. තල්ලු කරන්න ගියත් එහෙමයි මොකක් හරි. You will have to overcome the resistive force uh, to get any success. Right. If P is zero, then F is zero, right? Now listen carefully here. What if you from starting from zero, you are building up, you are increasing P gradually. As you increase P gradually, what happens to F? What do you think? Starting from zero, yeah, you are increasing P, then F will also increase, not just increase, it will increase equally and oppositely. Hmm? Equally and oppositely. That means we write that side F is equal to minus P, like this. Hmm? Uh, if P increases gradually from zero, then F will also increase equally and oppositely. Right? Equally and oppositely. But the thing is this, again back to our example, here it's not moving. I'm applying a small force, still not moving. It's trying to retain the motion, but here I'm increasing the force. But that frictional force, if it has some limit, I can increase this, not endlessly, limitlessly, but I can increase it to some extent. But the resistive force, it has a certain limit, right? Some practical limit. මට ඉතින් මේක තනියම තල්ලු කරන්න ගන්න මම කවිෂාවත් කතා කරගෙන තව උදව්වක් ගන්න. I can increase it that way. එහෙම නැතිනම් තව කාට හරි කතා කරනවා. ඒත් බැරි නම් ක්‍රේන් එකක් ගෙන්නලා හරි අදින්න. හ්ම්. එහෙම කියලා ඉතින් අපිට ඕන තරම් වැඩි කරන්න බෑ. සීගිරි ගල තල්ලු කරන්න පුළුවන් නම් මෙලහට අපේ මෙල්ල එක නේද? එතන සීගිරි ගල රළු කරලා මොකක්ද පුළුවන්. දැන් එහෙම කරන්න අමාරුයිනේ. තල්ලු කරලා පෙරලන්න නම් බෑ. පුළුවන් නම් මෙලහට පෙරලලා. But but you can increase P, but F will reach its limit. F has a limit. I'm not meaning P has no limit, right? P can you can increase P, but increase and increase, but not endlessly. But relative to that, F will come to its limit for these practical purposes, right? මම කිව්වාගේ සීගිරි ගල තල්ලු කරන්න අපි කට්ටිය උත්සාහ කරොත් ඒක හරියන්නේ නැහැ. නිකන් පොඩි දෙයක් නම් මෙන්න මේ කබඩ් එක තල්ලු කරන්න හැදුවොත් නේද? අපි දෙතුන් දෙනෙක් එකතු වුණාම that's as F comes to its maximum, we can increase P further. Okay. So I'll write, but F has the maximum as F reaches its maximum. Up to down, right? F is at its maximum. That resistive force, as it comes to its maximum, see what happens. What's going to happen? How to describe that instant? Is at its maximum. Is at its maximum, then මොකද වෙන්නේ? F is at its maximum. It can't now like hold it anymore. You increase P a little by a little, give a little increment to P. What will happen? Then F came to its maximum, right? The if it's a resistive force, it will try to keep this object in equilibrium. But as F is at its maximum, you are further increasing P, a little increment of P. What happens? The object will start to move, right? So this is the more important thing for us. As F is at its maximum, at that instant, the object is this object is just about to move. With a little push, it will move. Hmm? So that's state we say the objective or the surface sign limiting equilibrium, right? Uh, as F is at its maximum, we say the system is in limiting equilibrium. Limiting equilibrium, little increment of further little increment of T will move the object. Will move the object, right? Right. Uh, now the most important thing is that limiting equilibrium state, right? At limiting equilibrium state, there's something you can prove experimentally, right? In the laboratory. In the maths class, you don't go to the laboratory, right? In the physics class, for physics lessons, you have practicals. Hmm? This is something you have to show practically, right? And this is the most important thing in our theory. At the limiting equilibrium, state uh, practically it can be shown that for a given two surfaces, right? For a given two objects, a given pair of objects, at the limiting equilibrium, you can show that this normal contact force R and the resistive, that frictional force R and F, the ratio of them for given two surfaces, right? The ratio at the limiting equilibrium, right? Not always. At the limiting equilibrium state, the ratio of R and F is a constant. It is fixed. F divided by R is a constant value. But you change the surfaces, so take some other surface, then for this clip, that ratio at the limiting equilibrium, that ratio F over R will be a different value, right? So that the ratio depends upon the I'll explain it, what you call the nature of the surfaces. Right. So that's the most important thing in this lesson, right? At limiting equilibrium state for given two surfaces, we can practically show that uh, F over R at that state, F over R equals a constant, right? Uh, F over R equals a constant. The value of the constant, we just denote it by the notation, the normal standard notation is mu. Hmm? The constant is, but again, not always, right? At the limiting equilibrium state, this is valid. Hmm? The constant is represented by mu. So F over R equals mu at limiting equilibrium, and we get F equals mu R. At limiting equilibrium state, F equals mu R. Mu is some constant, of which the value depends upon, we said, the nature of two surfaces, right? That thing you can't explain, right? In all these theories, when you are explaining and explaining and explaining, you come to some dead end, right? No ultimate explanation to any theory. In this theory, this is a dead end. We say the value of mu is determined it depends upon the nature of surfaces. Then don't ask me what do you mean by nature of surfaces. Then in nothing. So that we see, like you can feel it. අතගාලා බලනකොට පේන surface එක නේද? මොනවද හොඳට මැදපු polish කරපු මේසයක් කළෑල්ලයිනේ ගඩොල්ලක් එතකොට and this is the plastic surface මේක අතගානකොට දැනෙන්නේ. And that's what you call, what you mean by the nature of surface, right? No ultimate explanations in any of the theories discovered by man. එමෙන්න නෑනේ. මෙතන මම ලියන්නේ එක මදි වෙන්නේ. Mu is called, what is the name? Mu is called the coefficient of friction between two surfaces. Hmm? Coefficient of two surfaces. අනිත් තව ටික විස්තර තියෙනවා. ඔය ටික ලියා ගන්නකෝ. ඔය ටික ලියා ගන්න අපි ඉස්සරහට යන්න කලින්. Right. Now, what determines the value of mu is the question. Let me just explain it not very deeply. The value of mu is determined by, as I said, the what you call the nature of the surfaces. Nature of two surfaces. Uh, as I said, you can't give an ultimate explanation to that, but uh, we can say what are the things which do not involve in this determining the value of mu. Hmm? Uh, for instance, taking this number one, frictional force. Sorry, I have erased the diagram. Frictional force F can change, but not mu. For given two surfaces, mu will remain the same, not affected by the other factors. So, for example, now this surface is in contact. It has some area. Now some area of contact, right? Now if I change it to this, as long as it is the same material, right? Same material. Now changing the area in contact, mu will not change. So mu is not determined by the area in contact. Okay, frictional force can change, but not mu. The other thing is the weight. You can say make the weight say increase it by say twice, thrice. By doing so, you are increasing the value of R also. Say R is increased three times, then at the limiting equilibrium, if you uh, increase R three times at the limiting equilibrium state, then F will, what happens to F? At the limiting equilibrium state, F will also be increased by increase three times. Hmm? That is keeping the ratio the same. So the value of mu is not determined by the area in contact. It's not determined by the weight, right, or the mass. It's determined only by the nature of surfaces. And then don't ask me what do you mean by the nature of surfaces, right? But not by the area, the surface area in contact. Like and mass of the objects, right? One more thing in this, Number 7, we said that this is what happens at the limit equilibrium state. At the limit equilibrium state, F has reached its maximum, right? F has reached its maximum. So, in other words, F maximum is equal to mu r. The object is, the system is just about to lose the equilibrium, right? Now, it's for equilibrium. What is the requirement then? For equilibrium, equilibrium, equilibrium means before it reaches the limiting state, before reaching the limiting state. At the limiting state, f equals mu r. This is the maximum value of f. And before that, yes, Abhita, what is the requirement? If maximum is mu r, that's at the limit equilibrium. When the equilibrium is just about disturbed, right? And before that, f has to be less than mu r. F maximum is mu r. So in normal equilibrium, f has to be less than mu r. Got that? Hmm? So that is the requirement for equilibrium. F is less than mu r, but there is a problem here. One might argue that at limiting state, again limiting equilibrium, there also its system is in equilibrium. Hmm? So whether to include equal here or not, it's like controversy. There's a debate. You can argue upon that, right? So don't waste your time arguing upon things like this. You can argue on either sides. The best thing, if you are working out, say, a past play problem, and decide whether, look at the answer. In the answer, if you get the answer including equal, then include it. If in the answer you can get the answer without that, then don't include it. See how the other person thinks about that, who sets the paper. You write your answer accordingly. Are it? Because there is no like a definite agreement about that. එහෙම දේවල් තියෙනවා අපේ තව ඕන තරම් තියෙනවා. What happens at the highest point? මොකද වෙන්නේ? Velocity is zero. The object is at rest or not. Hmm. One might say at the maximum height, for a moment it's at rest. Then another person might ask, if it is at rest, then how it comes down after another while? Hmm? ඒ වගේ ඕන තරම් ආගය කරන්න පුළුවන් යන තියෙනවා. වෙන වැඩක් නැති මිනිස්සු තමයි. ඔය වගේ වලක් නම. So you look at the answer, then decide whether to include equal or not. ඔක ලියාගන්න තව කාරණයක් තියෙනවා ඉගෙන ගන්න. In the theory. Friction ඔයගොල්ලන් ටිප් එක දාන්නේ නේ. ඉස්සර නෝට් එක ලියාගත්ත මම බලන්න. ඔයගොල්ලෝ හරි බේසුරු පොත් තියනවද? මම කොහොමද මගේ ගණන් එකයි දෙන්නේ මේ පාඩමේ. කලින් පාඩමක් තියෙනවනේ. මගේ ගණන් එකයි දුන්නේ. ඉතුරු ටික ඔක්කොම පාස් පේපර්ස් වලින් කරේ. Gradually selecting carefully questions from past papers, we can build up the mass key pen ඉපාරට. මොකද දුන්නේ ස්මූත් ඩෙන්ට් ගණන් අඩුවද? කරගන්න පුළුවන්. ගණන් පහක් හයක් විතර තනියම හදනකොට තේරෙනවා. පැක් එකට එනවා. ඊට පස්සේ තාටියක් හදන්න ඕන ස්පීඩ් එක වැඩි කරගන්න. නැත්නම් වෙලා යනවා. ප්‍රැක්ටිස් එක ඕන. It's another important thing in our theory, right? Okay, the idea. Right? The thing is this earlier, especially in the first section in statics, after we are gradually building up statics, right? We started from vectors. Then, using the theory of vectors, we build the theory of systems of forces completely upon what you learned in the previous section, right? Vectors. We use vectors to build the theory of systems of forces. Then, the knowledge we gathered in that, we have taken to the next topic, equilibrium under three forces. And using them, we came to the next one, smooth joints. Now, uh, in this section also, you are going to see problems. The problems that we are going to take, you will see apparently very much similar to the problems we have taken in equilibrium. Hmm? We have taken in equilibrium, for instance, අපි නිකන් ගන්නනේ මේ වගේ වනේ something in equilibrium somewhat in sphere ඔම වෙන්න පුළුවන්. දැන් මේ වගේ අපිට කරන්න බැරි වුණා. So you can't keep things in equilibrium like this without friction. ඉස්සලා යනවනේ. So somebody has to hold it. If not, if there is no friction from external force. Uh, Now the thing is, in equilibrium under three forces, to solve those problems, we had three rules. Basically, we used three rules. One of the three rules, there was another also. Three rules: Lame's theorem, then triangular forces, uh, resolution and moments. Ekanam no problem. One not necessarily three forces, right? For three forces only, you can apply triangular forces, Lame's theorem, and Koch rule. Hmm? We have many tools that we use to solve problems of equilibrium under three forces. Okay, but when you come to now from smooth surfaces, when you come to rough surfaces with frictional force also, what happens? This is similar. This you are taking now the same problem that you have taken earlier. Earlier we have marked only the normal contact forces R1, R2, taking the surfaces as smooth surfaces, contacts as smooth contacts. Then මොකද වෙන්නේ? Now here three equilibrium under three forces. You can apply your previous theory. But now, if it's rough, not smooth, in addition to these forces, you will have to mark frictional forces also. Frictional forces also. The three becomes equilibrium under three forces earlier. Now that can change to either four or it might be even five. Now can you use them directly? Triangle of forces, Lamy, especially Lamy, triangle of quad rule. Yeah, we are losing that opportunity of using them with more and more forces. But resolution and moments, okay, no restriction for that, right? Once you mark forces with F and R, so F1, R, F2, R1, R2, that way, and with FNR, if you mark the, the forces at this point of context by FNR, I mean two perpendicular forces, right? That's like the Cartesian way. If you mark them like Cartesian things, then you lose the opportunity of using especially triangular forces very rarely anyway using uh, especially Lamy and cut rule, right? If you mark the forces like this, then you the only opportunity, the only method you have, only tool you have is to use resolution and moments. And that's one way of solving problems, right? And the second thing is, if you are strictly determined to apply Lamy or maybe cut rule, now can't you find a way? You have those tools in your box, but without using them trying to solve problems, it's a disadvantage. Can't you find a way? In other words, reducing the number of forces back to the problem is now it was three under three forces. Now marking the frictional force, it might increase to four or five. So can't you take a system back to three forces? If so, if you are able to do so, then you will be able to use those tools. Lamy, triangular forces, chord rule, so it opens another door. Hmm? මොකද කරන්නේ? Reducing, to reduce the number of forces back to three, you can do so. What should you do? A simple solution to the problem. Here, without frictional force, it was just one. With the frictional force, it became two. Now we want to make it back to one. What would you do? Take it back to one. Without friction, it was just R1, one force. Now, taking together with this, it increases to 2. But if you want to bring it back to 1, a single force, isn't there a way? Abhi tina tau kawra rinna nama dala nathi. Whoever I'm asking, apply an opposite force. No, no, no. That's not the idea. Abhi, it's much a simpler thing I'm saying. Can't guess. Kawra rinna nama dala nathi tawara. Take the resultant. Yes. ටිකක් කල්පනා කරනකොට එනවා ඔළුවට නේද? Take the resultant of them, Abhita. Very simply, back to a single force. Here you have two forces. Take the resultant of them, you are back to a single force. Then the other one should pass this point. Now this see from smooth to rough. Hmm? With smooth surfaces, the weight was acting here. Now if it's a rough plane, then it changes its position. Weight should be somewhere here. Hmm? Then mother, you can bring it back to sometimes reduce the number of forces taking the resultant of FNR at the points in contact. Hmm? We will explain it formally. And our new topic is angle of friction. Right, angle of friction. I'm going to draw the same diagram, but it's something new. Uh, okay. So I wanted to say now there are two ways of attempting a problem of friction. First method is uh, first method is drawing things in the diagram in FR. Then the only option you have FR things Cartesian way. The only option you have is to use resolution and moments because number of forces can be 4, 5, or more. The second attempt is you can take the resultants and bring the number of forces back to 3, then see if you can apply Lami's theorem more or to law very rarely triangular forces. So there are two ways of attempting or planning your solution to a given problem. Then earlier we discussed one method. This is the second, not the method we discussed. We discussed the principle for the first method. This is the principle for the second method. Okay. It's like the same diagram I am drawing R, but the thing is I am drawing F here, and this is the force, force trying to pull it. Okay. We are taking the resultant. Hmm? And we are going to consider some angle. Make it to of the resultant force. We are going to take the angle with the normal contact force, right? Not with the friction. To the normal contact force. Let that be some theta. Hmm? Uh, so let the resultant of this be S. F plus R be equal to S. Let theta be the inclination of S with R, right? To R. කට්ටිය ඊළඟ දවසේ එන්න ඕනද? ඊළඟ දවසේ කියන්නේ not 70 18th 25th you have to be here. එතකොට no more online classes for English medium 2021. Today is the last one. Hmm? Whether you happy or not, I don't know. ගෙදරින් නම් පුල්ලා අතල්ලේ පන්ති කරපු කාලේ ඉවරයි. දත් මදින්නෙත් නැතුව උදේට. කබක් වෙලාගෙන උණු කෙල පෙරාගෙන ඇවිල්ලා වාඩි වෙලා පන්තියේ ගෙදරින් නම් පන්තියේ තින්නේ 10ට නම් 9:55 විතර නැගිටලා දුවගෙන ඇවිල්ලා එහෙමනේ නැද්ද? නැහැ. අන්න තමයි හොඳයි. වැඩි දෙනෙක් එහෙමයි. ඒතකොට රෑ 9ට ඉඳලා තමයි උදේට ධර්ම දින්න තියෙනවා. ඒ කාලේ ඉවරයි ආ. ඉවරයි කියලා හිතමු. දැන් එන්න වෙනවා මේ දවස්. Of S with R, then if I can find tan theta will be equal to tan theta F over R. Then R F over R, right? The same thing that as we have explained earlier. P is 0, then if P is 0, then F will also be 0. No F, theta will be 0. Right? You increase P gradually starting from 0. F will also increase equally and oppositely. What happens to theta? Theta will also follow. Uh, as P increases from 0, F will also increase equally and will increase. So will so does theta. Right? And as F reaches its maximum, that is at the limiting equilibrium state, what happens? Oh, Sunday කට්ටිය Sunday ඉන්න. Thursday ආපු ළමයි Thursday ඉන්න. Not next week. මම ඊයේ කිව්වනේ. After 18th, right? Next week there will be no classes. You can enjoy. How do you? That is in the week starting from 19th. You have to come physically to the classes. Sunday students can come to the Sunday class. It will be started on 25th. Thursday group can come to the Thursday class. Normal class. Thursday class we can start at 3:30. Then 4 o'clock here no 9. You are not going to school. We start at 3:30. Then after that we'll discuss whether we can bring it down to 3 even. Sunday class we started at around 8 on 25th, right? We will start at 8. It will go till 12:30, 1 o'clock, right? From 25th the Sunday class, from 22nd the Thursday class. No more online classes unless the corona starts to spread again. Nobody knows. Right. So does theta, right? එතකොට මොකද වෙන්නේ? As P increases, F will also increase, increasing theta. හරි. එතකොට මොකද වෙන්නේ? At the limiting state, F reaches its maximum. Then what will happen to theta? At the limiting state, F increases, F is at its maximum. So does theta. Theta will reach its maximum. Maximum value of theta. Let's name it some lambda. That's in the limiting state. At limiting state, let theta max be equal to lambda. Hmm? Then then tan lambda is equal to f over r at limiting state. This is equal to මේකයි මට කියන්න ඕනේ. Now here we said that there are two ways that you can plan your answer for a problem of friction. One way is taking the Cartesian, marking things the Cartesian way, FR. Then you have to use resolution and moments. And the second method is, so in that diagram, you have F and R as unknowns. Now, when you take, instead you take the resultant of them, number of unknowns, how many now? Taking the Cartesian way, you have two unknowns, F and R. Taking the resultant, how many are there now? Yeah? What are they? No, after taking the resultant, we are not going to consider them. You forget these and you're going with S. That's what we wanted, to reduce the number of forces. But my question is, you can reduce the number of forces by taking the resultants. But will that reduce the number of unknowns? එම magic දාලා number of unknowns අඩු කරන්න පුළුවන්ද? Taking Cartesian way F and R, two unknowns. You take the resultant as a force, there is only one. But number of unknowns, what are they? Yeah. When you mark F and R, you know exactly the direction of them. But when you do S, you don't know the angle. So still two unknowns. Magnitude of S and direction of S. S and theta. Number of unknowns will remain the same, but number of forces you can bring down sometimes to 3. Is that clear? Still number of unknowns will remain the same. If you are trying to solve the problem with the Cartesian form F and R, now compared to the smooth surface case, no friction, say you have taken some three equations for three unknowns, two equations or three equations. Now with the friction there, you have more unknowns, F1, F2, more unknowns. That means you take the same problem, right? We solved earlier of smooth surfaces, obtaining equations. Solve the resolution, movements, whatever. Right? The resolution and moments, you solved it earlier with resolution and moments, taking say 2 or 3 equations. Right? But now with friction, number of unknowns will increase. You have to mark F1, F2, the frictional forces also. That means you need some extra equations to solve them. If there is only one F, you will need one frictional force. If there are two Fs, 2 points in contact with rough surfaces, you will need another equation. What is the other equation? How to take the other equation compared to the smooth surface problems? Say you have solved the problem with smooth surfaces. Now the same problem given with frictional force. That is rough surfaces. Then now you have more unknowns. That means you need more equations. So how to get more equations? ඔච්චර දාගෙන හිටන්න ඕනේ නෑනේ. ඒක තමයි අපි ලිව්වේ. මොකද්ද? මෙච්චර මාන්සල ඉගෙන ගත්ත ඒක. This is the equation. If in contact at one point, F1 equals mu r1, if you have two such points, You will write x2 equals mu r2. එක පිනට හම්බ වෙනවා ගාන පටන් ගන්නකොට. You need extra equations. Those equations you will get very easily. පිනට ලැබෙනවා ඒක. මහන්සි වෙන්න ඕනේ නැහැ. තේරුණා නේද? Considering the limiting equilibrium, you can start by writing this. But if you try this way, still number of unknowns will remain the same. Instead of FR forces marking in the diagram, if you are going with S is the resultant, still number of unknowns will remain the same. Then ලාමි දැම්ම නම් මොනවද කොට්ටුවේද triangular forces මොනවාරි දැම්ම නම් still you need some extra equations, one or two. කොහොමද ඒක ගන්න? The extra equation matching to the new situation, what we are learning in the new section. කොහොමද ඒක ගන්න? එතනට තමයි අපි දැන් ඇවිල්ලා ඉන්නේ. At limiting state මොකද වෙන්නේ? FOR limiting state FOR is equal to mu. So tan lambda equals, this is the extra equation, tan lambda equals mu. එක තැනකදී නම් rough surface එකක් තියෙන්නේ, you write tan lambda equals mu. තව තැනක තියෙනවා එතනටත් දාන්න. So you can get the extra equation. With this, if you are going to solve the problem reducing the number of forces to 3 and using Lami's theorem or Corpus law, whatever. අනිත් විදිහට ගියා නම් Cartesian form එකේ there also you need extra equations. You get them by writing f equals mu r. නෝක තමයි අපි මෙච්චර වෙලා කතා කරලා ඉගෙන ගත්තේ අන්තිමට. උදේ පැහැදිලිද? සචින් අභිත, is that clear? The way we are going to we are going to solve problems of friction. Is that clear? Yes. Okay. Now take it down. After this we can start problems. හැබැයි මම එකයි දෙන්නේ මගේ ගණන් මට ඒක බෝඩ් එකේ ලියන්න පුළුවන්. එතනින් පස්සේ කෙලින් පාස් පේපර්ස් ගණන් හදන්නේ. අද අපිට එකක් තමයි මම දැන් හදන්නේ වෙන එක්ස්ප්ලেইন කරන්න අපිට. මම ටියුට් එක දැන් බලලා දාන්නම් ගෲප් එකට කොකටත් හා. දැන් දාන්න බලන්න. ඔයගොල්ලෝ මේක ලියන්න මම එතකම් බලන්න ටියුට් එක දාන්න. අද ඕන වෙන්නේ නැහැ. අද හදන ගාන මම දැන් බෝඩ් එකේ ලියන්න. Ancora dia nanni kalau ini kan. So we'll start with the examples. Number one, mang group එකට දැම්ම ළමයි ටියුට් එක දැන් ඒක ඕනේ නැහැ. පළවෙනි එක ගානක් හරි පොතේ ලියන්න බෑ. ඔක්කොම ටියුට් එක බල බල ලියන්නේ. මම ගානක් දෙකක් හැම දෙන්නේ ඒකයි මොකද බෝඩ් එක දාන්නේ. පාඩම කරගෙන යන පොතේ නෝට් එක ලියනකොට එක එක්සැම්පල් එකක් හරි ලියන්න බෑ. නැත්නම් නෝට් එක ලියුවා ටියුට් එක. question number 1 2 in දාගෙන යනකොට පොඩ්ඩක් විතර ගන්න. Man lihat aku. Right. Example 1. Ladder AB is of length 4 meters and mass 12 kilograms. Very good. 8 kilograms. It is in equilibrium in a plane. It is perpendicular to the vertical wall with an cage resting on ground and in B is in contact with the wall. 3/5 and 2/5 are the respective positions of friction. Between the ladder and the wall, ladder and the floor, and the ladder and the wall respectively. Limiting equilibrium it is in limiting equilibrium. Limiting equilibrium, right? No problem, I can write it here. Find the inclination. Inclination of the ladder with the horizontal if it is in limiting equilibrium. Now the inclination of the ladder to the horizontal is changed to 30 degrees. Change to 30 degrees. How far the boy of mass, small little boy, of boy kita juga orang girl kita lihat of mass 8 kilograms can climb on it without the ladder being slipping. Before the ladder. Slips. Then draw diagram, mark everything that you need, and start it your way. Start it. Take it down, then try to figure out the question, draw diagram, and do something. If you are marking things with FR forces, You write F equal mu r in addition to what you did earlier. If you are going to work it out with resultant forces, you start by writing tan lambda equals mu. කොච්චරයි ඔලිට ඒක. ඒක ටික පරණ පාරම තමයි. අර කලින් ආණ්ඩුවේ වල මේ ආණ්ඩුව ගෙන්න ගත්තා වගේ බැලු ගන්නවට විතරයි වෙනස. අනිත් ඔක්කොම එකයි. Right. Theoretical extended diagram on one side, all your workings on the other side. Okay, पत्र में पत्र कर लेना आगे आगे के तो तुम्हारा प्रश्न है यस देखा थे मानने के मैं पत्र को भी देना मेरे F2 है ना ये सिंपल W में पत्र में होगा कैपिटल W है ना एक्सएम के दिन कराने ना होते then गाना हमारी इधर डायग्राम में आते නැත්නම් ඔය කොහොම මානසික හදලා ඒ ආන්සර් එක නැත්නම් දාගෙන යනවා කියන්නේ ඒක පේන්නේ නැහැ ආයෙ බලන්න ඕනේ. දෙකම හැන්ද කාටිසියන් ෆෝර්ම් එකක් දාලා රිසල්ටන්ට් එකයි දෙකම ගත්තා රිසල්ටන්ට් කියන්නේ ඉතින් කාටිසියන් ෆෝර්ම් එක බලන්න ඕගොල්ලෝ වැඩි පුරුදු එකනේ ඊට පස්සේ නෙගටිව් What is the weight of mass of the ladder? 8 and 80 Newton. Length is length given 4 meters. At the beginning. Length එක දුන්නේ නැද්ද මම? තියලානේ 4 meters කියලා මම මතකයි. So 2 meter and 2 meter. And we have to mark the frictional force, right? Sorry, normal reaction here R1 and here R2. This is the NA, and A is resting on ground. Now, in which direction it tries to slip at this point? Away. Then the frictional force, resistive force, should be towards the wall. Yeah, correct. At that end, at B, it tries to slip. At this end, tries to slip down. The frictional force then should be going up. And we want to find this angle, but at limiting equilibrium. If you mark things like this in FR form, that is, you are going to apply resolution and moments and nothing else, right? But if you choose that path, then there is something you can start with. පිනට හම් වෙන එක තියෙන මොනවාද? Limiting equilibrium. ඉස්සලා ඒක කියන්නේ. පිනට හම් වෙනවනේ. මොනවාද? The limiting equilibrium. Another minute. If equals mu r කියලා යන්න පුළුවන්, but at two ends. මෙතන mu කියන්නේ with the flow, ladder with the flow 305. And the other one mu 1 කියලා දාන්න මෙතන. And there mu 2 is 205. පිනට හම් වෙන එක ඉස්සලා ගන්න එපා. F1 equals mu is 305 R1, then at that end F2 equals mu is 205 R2, if you are planning to work it out like this way, the first method, and you can start from this. මේක ලියනකොටත් ලකුණු දෙනවා හොඳ. diagram එක අඳිනකොට ලකුණු දෙනවා. මේ දෙක ලියනකොට ලකුණු දෙනවා. එහෙම කළත් හැම අවුරුද්දෙම ලකුණු බිඳුව ගන්න ළමයි ඉන්න සෑහෙන ගානක්. ලකුණු 10ක් 10ක්වත් ගන්න බැරි ළමයි ඉන්න around 20%. මේ නිකන් තිනට දෙන ඒවාත් තියෙන මොන තරම්. තිනට දේ ගන්න දෙන දේ ගන්නත් පිනට දෙන දේ ගන්නත් පින් තියෙන්න ඕනේ. අර මොකක්ද තියෙන්නේ? උපනත් ප්‍රේතව පවකට නොපනත් කලකත් නොලැබෙයි සෙන්සොටු පවන. අර වෙනනේ. උගුරත් නොතැමෙයි සුරගඟ වැටුණත් කියලා තියෙනවා. සුරගඟේ වැටුණත් උගුර තෙමෙන්නේ නැහැ. තිබහෙන් ඉන්නවා. මම කරන්නේ ඒක තමයි කවදාද. right. මදකුත් පින්ම කළා කියන්නේ සිද්ධ. ඒකට කොහොම හරි මම වන පිටට හම් වෙන දෙයක් ගත්තා. now දැන් ආගන්න මට උත්තර දෙන්න. now we have to plan it. We want to find theta. So finally you will need an equation that contains theta. How to get that? How to get an equation? නිකන් කනා ගහන්න බෑද? plan කරලා කරගෙන යන්න. How to get an equation containing theta? If I can Abhita, Sachin, and whoever else is there. How do we get an equation containing theta? Petty hitanna onne. Poti deya hitanna තියෙනවා. To get an equation containing theta, what do you do? Yeah. This way. We started from this now, not with. අනේ මේ මදන් පුළුවන් එක අපි ඊළඟට හදන්න. මට උන්නේ මේ දෙකම පැහැදිලි කරන්න. We start with this. That's why we wrote f equals mu r. Now we have to move ahead with this. Taking moments about considering b o a b දෙකෙන් ඕන එකක් ගන්න. මම නම් කැමති මට අත ළඟ තියෙන්නේ a. I'll take moments about a. අතරින් ගත්තත් කමක් නැහැ. මේක ටික ළඟ තියෙන නිසා වෙනසක් නැහැ නේ. Taking whether around a or b, it looks the same. හරි ඔහම බලාගෙන ඉන්න. So you are saying saying to take moments about b. මම ලියන්නම් about a කියලා for the system, right? About a, if you are taking moments about a, will theta be the only unknown involved? You are going to take moments about a. ටක් ගාලා theta එනවද දලස් ගාලා? නැහැ. In addition to theta, there will be r2 and f2. Right? They will involve f2 and r2. That means you need to find f2, r2 before taking this moment equation. Now tell me, how to find f2 and r2? Forget this for a moment. Now, how to find f2 and r2? What do we do? මම ඉස්සලා කිව්වේ වැඩි හිතන්න දෙයක් නැහැ කියලා මම නිකන් නෙමෙයි කිව්වේ. We have only two tools. If you are to work it out this way, you have only two tools. Another resolution and moments. Theta resolve karo theta either. Resolving in any direction for these forces. No. So it has to be a moment. Now my second question, you have to find f2 and r2. For that you need the equations. How to get the equations? How do you get the equations? Intending to find F2 and R2. Yes, अभी तक कौद कठिन F2 R2 equals F2 කියලා දාලා තියෙනවා අභීත. Yeah. R2 equals F2 නෙමෙයි. R2 equals F1. Yeah. ඒක තනි වචනෙන් කියන්න තිබුණා. What do you do? In one word, you resolve. You get this F1 equals R2 resolving horizontally, but that will not be sufficient. At least we have two unknowns F2 R2. හැබැයි locally යන ගියාම F1 එනවා. Three unknowns. So we'll get another equation by resolving vertically also. මෙතනත් පිනට හම්බෙච්ච දෙකක් තියෙනවා. So you get four unknowns, right? F1 R1 F2 R2. So you need four equations, but two are already there. So you have to find the other two only. One you get resolving horizontally, the other resolving vertically.